we've got 2/6 of a pizza. What does that even mean? Because we have 2 slices here. That's where that 2 comes from. And if we put all of these slices together, you get 1, 2, 3, 4, 5, 6, 6 slices of pizza. So 6 total slices. And we're gonna look at just eating 2 of those out of the whole 6. That's how we get the 2/6.
Keenumbers.
2/6 is really a lot to say. It's a mouthful, so let's make it easier. You'll also notice that when we cut this pizza into 3 equal piles, this 2/6 is the same thing as a third. 1 slice here, plus 1 slice here. Yep, that's our 2/6. And conveniently, Legos, what are you doing here? Conveniently, when you put all of these together, you're gonna see, oh yeah, we have a third, and a third. So 2/6 is the same thing as 1/3. 2/6 is 1/3. They are what we call equivalent fractions. EQUIVALENT. They are equivalent fractions, which is just a fancy way of saying they're equal. Yeah. 2/6 of a pizza, 2/6 of anything is the same thing as 1/3. 2/6 equals 1/3. I need a 3/4 inch bolt.
I only have 6/8.
Then we have what we need.
Like that. 9/12.
Done. All right, if you have, how many trains here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 trains, 10 total. And you want to start looking at equivalent fractions. Let's start with some easy ones. How about if we have 2 trains? 2 trains out of all 10. Well, in terms of fifths, if we have 5 equal piles, how many fifths are we working with? Wait a second, this problem's rigged. I already have it in 5 equal piles. 1 pile, 2 pile, 3 piles, 4 piles, 5 piles. They are equal because each have 2, just like we started with, 2 trains out of the 10 total. This is a big whopping 1/5. 2/10 is the same as 1/5. Here's another classic example. We have 1 stick of butter. Doesn't look like butter. Okay, so we have 1 stick of butter, and then we have here, cut it into 2 equal halves. 1/2 plus 1/2. 1/2 plus 1/2. That's equal to 1. But over here, we have cut the stick of butter into quarters. Well, a lot of sticks of butter, is that the correct English? A stick of butter often will be divisible by 8. In fact, they will do it by 8 tablespoons, I believe. So this is not out of the realm of possibility. This is a quarter plus a quarter plus a quarter plus a quarter plus a quarter. Did I say it enough times? You have 4 quarters here. 1, 2, 3, 4. So we have 1, 2, 3, 4 quarters. And when you add, what the deuce is going on here, Lego? When you add them all together, you get 4 quarters is equal to a whole. So how does this help us with equivalent fractions? What if we have 4 trains out of the 10 total? Better make 2 of these ellipses here. 1, 2, 3, 4. You have 4 trains out of 10 total. How many fifths are we working with right now? Well, again, I've already divided the trains into 5 equal piles. So, pile 1, pile 2, pile 3, pile 4, pile 5. This is easy. We have 1, 2 piles accounted for, or 2 fifths. That is a sloppy looking 2. What is going on here? Okay, fix that too. I made it even worse. That's just awful. Okay, 2/5. 4/10 is equivalent to 2/5. We have 4 out of the 10 trains, or 2 piles here. When we make these trains 5 equal piles of trains. When we make them into 5 equal piles of trains. And you can continue in this manner. Ha 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 ha. You can look at, what if you have 6 out of the 10? What is that in terms of fifths? If you had 6 trains, oh, let's add another ellipse or potato here. There we go. We have 1, 2, 3, 4, 5, 6. 6 trains out of the whole 10. But how many fifths is that? Yep. If you already saw the answer here, then you are a rock star. 3/5. 3 of these 5 piles. That's the same thing as 6/10. They are equivalent. Yeah!
Keenumbers.
We're in the bonus section. What about 4/6? What about 4/6? That means we are going to look at 4 out of these 6 slices.